from CMA Wind and can you hear me? Okay, hi, I'm Yueming from CMA Wind and Solar Center. I would like to share our key technologies in the program cooperate with CNEC, focus on solar energy resources evaluation and PV potential in low latitude area. Next slide, please. And the presentation includes two fields. One is process on Formula 4A SSI products application, and the other is the effect of inhomogeneous meteorological conditions on PV generation. Next. Here's a brief introduction for Fengyun satellites. Fengyun is the Chinese word for wind and cloud, which means that this series of satellites are aimed for meteorology. The video in the top left shows this video. It shows the 7 Fengyun series satellites currently operating in orbit, including the polar, orbiting, and geostationary. I think many of you are the users of Fengyun products. And the table on the top right shows some basic info on Fengyun 4A, who is the first flight unit of the Fengyun 4 series. And on top of that, I'm pleased to share with you that Fengyun 4B, the second flight unit of the Fengyun 4 series, was launched in June 2021 and is on triennial operation from the June 1st this year. The SSI data used for solar energy evaluation will be released later, and it can be downloaded on the official website of the National Satellite Meteorological Center. Next, please. Next, okay. Here shows the Fengyun 4A full disk map and the irradiance distribution in Philippines. In our project, we are going to evaluate the performance of Fengyun 4A products in Philippines. Next. Here's the location of the inset stations. The stations mainly in the offshore area of China, and which are all in the latitude areas, including the BRSN, the Ocean Boil Stations, CMA Radiation Observation Station, and Hong Kong Observation Radiation Observatory. Okay, next. And here shows the validation results. It can be seen that the Fengyun 4A products performs well in low latitude area. And the results from the Balon Boil stations shows that there's no big difference for the performance between the land and sea. And for the next step, we are going to further analyze the performance of Fengyun 4 products with the ground-based observations in Philippines. Okay, next, please. Here comes the second part about the effect of the inhomogeneous meteorological conditions on PV generation. And here's the purpose and the significance of our study. The photovoltaic panels facing source under the normal conditions, while the radiation asymmetry characters can have an impact on the optimal azimuth. The reason for the asymmetric distribution of the radiation is related to many factors, such as clouds and visibility. The next, please. And to further illustrate this point, we choose Urumqi station and analyze the radiance of 10 years in AM and PM respectively. It found that both AM GHI and dBi is higher than that in the PM. Next, please. This slide shows that the asymmetric variation of daily irradiance is characterized by climate, month, season, and year. Next. Oh, sorry. In condition of the fixed inclination, we calculate the GTI for each azimuth. The result shows that the optimal azimuth is 11 degrees east due south rather than south. And at this azimuth, the year value of GTI increased by 4 kilometers per square. Next, please. And in condition of the seasonal adjustment, we found that the absolute value of the optimal azimuth angle is maximum in summer, and there's internal variation of optimal azimuth. And next. In our project, we would like to analyze the radiation in Philippines based on the same technical lines, find out that effects of the and find out the effects of the inhomogeneous meteorological foundations on PV generation. And to sum up, ground-based observations in Philippines are important for us. And a sincere thanks goes to the SNAC group and Pagasa for your help in the data support. Okay, next. Here's the outline of the work plan. And next slide, please. So if you are, next slide, please. So if you're interested in our work or have any advice, please contact us. Okay, that's all. Thanks.